So in this presentation I will mostly talk about rooms with absorbent ceiling treatments and how we try to estimate and characterize those rooms by using different type of room acoustic descriptors. But now if we look at our ordinary rooms like schools, offices and hospitals, well, it's more about reverberation time still, even since it was more than 100 years since Sabin's discovery. It's still the dominating parameters in recommendations and standards. There is one exception, and that is the new office standard where there are other measures. In fact, the reverberation time is not included at all. Why do we need more parameters for these type of rooms? I will just start with showing you an example of a measurement that we perform in these two quite small meeting rooms. They are the same size, the same volume, the same height. The only difference is that in room number 1 here we have an absorbent ceiling with highly efficient absorption, alpha value almost close to 1. And in the other one we have a more reflecting ceiling with an absorption coefficient 0.1, weighted one. Then we did some typical room acoustical measurement in these two rooms. We measure the impulse responses and we calculate the reverberation time, and we also calculate the speech clarity and the loudness level, the sound pressure level in the rooms. And when we look at the reverberation time, we got this figure, which might be a little bit surprising. As an acoustician, you maybe, well, there are some differences, some frequencies, but they are quite similar, which maybe is a little bit surprise. But that's what's happened. But now if we look at the C50, then we got quite clear differences of several dBs, in spite of the fact that the reverberation time were more or less the same. And then we measured the sound pressure level. We put a constant sound power source into the rooms and measure the level, and also here it's a clear difference between the two rooms. But as you see, we don't see those differences in the reverberation time. We also did another small experiment that we put in some wall panels, just 4 patches, 600 into this one room number 1 here with the highly absorptive ceiling. And then you see only this small amount have a quite large effect on the reverberation time. And even on the speech clarity, but not that much on the sound pressure level. Okay, so our conclusion is that at least it could be good to evaluate this type of room with ceiling treatment with the reverberance, the speech clarity and the auditory strengths. For more open plan spaces there are some other measures, but I will not go into that now. Idea is here to divide the sound field in these rooms into 2 parts. One part dealing with the late reverberation time and one with the early part. And using this, so to say, the same approach as Baron, creating expression for the integrated energy for the early part and the late part, we get a little bit more complicated equations, because in this case now we have 2 decay factors, one for the non-grazing and one for the grazing. But we also need to have some factor that estimate the energy ratio between those 2 fields. But the most important thing here is that, here we can include an equivalent scattering area, meaning that because the interpretation of scattering here is that if we put furniture into a room, the main effect will be to, as I show, convert energy from the grazing field to the non-grazing. Is that I think it's quite clear that we really need more parameters than the reverberation time to evaluate acoustics in rooms like classrooms, offices, and this type of rooms with ceiling treatment. I think speech clarity and sound strength seems to work quite well, and we can estimate them as well. But of course, I think the main importance is that we measure at least parameters that are related to speech intelligibility or are related to the noise levels. And for engineering purposes, I think this subdivision into a grazing and non-grazing works quite well. But what is quite important is that we have a method to quantify the scattering of furniture. And the way I did it here is quite simple. I mean, I think sometimes in standards it could be good to have methods that is quite close to reality. I mean, we have this ISO 354 standard where we measure the absorption coefficient, but that's quite special conditions. It's a diffuse field, it's a reflectors, it's a small area. It differs quite a lot from what we have in practice.